Welcome to General Structures 2 and Lateral Forces, lesson number 4, example number 4. And it gives us a 3-story apartment building in seismic zone A. Let's go ahead and write that down. Zone A, wood frame bearing walls with plywood shear panels. So shear panels. Panels, plywood. Soil conditions and period are unknown, so that's alright, we don't need to write that. What is the base shear as a percentage of dead load of the building? And that's, if you remember, if you go back into the study guide, you can see that the equation that we want to use, I'll go ahead and switch colors here, is this. Shear is what I'll call that, equals ZIC over RW times W. That's kind of the load there. And since it says what is the base shear as a percentage of the dead load, so what we're looking for in this is right here. So this is going to be the percentage times this will be the dead load. So it asks us what percentage do we want. So we need to look at this. And we'll go around and say, okay, how do we get this? Z you get from a table. I you'll also get from a table type situation typically. That's the importance factor. Z is, or I guess C is what we used earlier. The C is actually in this situation, since we don't know, we don't know what, if you remember from last example, C equals 1.25 S over T to the 2/3. And it says the period is unknown. And if you remember to find period, T equals, you needed to know the height of the building and the, I think it's CT, which came off of we'll just write the equation. CT came off, it was just a coefficient or a constant that came off a table per se. You could have chosen 3 different CTs, and HN was your height of the building, which we do not know. It's 3 stories, so you could assume something. But in this case, if you remember from reading through the study guide, as opposed to going through this and making an assumption for HN when we don't know it, we can just say C is, you use a max. We just use the worst case scenario of 2.75 for C. Alright, so we know C. Z, you have to go to table 16.1 and is reproduced for you on page 82. So go to page 82 real quick, and you will see seismic zone. Remember, we're in zone A. So let's go down to zone A. Actually, I said zone A. It looks like it's zone 4. I don't know why I said zone A. Anyways, zone 4, looking back. And zone 4, you go over to zone and you see 4. And Z equals, where should we put this? Z equals 0.4 for zone 4. Maybe my A looked like a 4 up there. Anyways, so we have Z. The importance factor. What is our importance factor? And you can go to table 16-K, which is your occupancy category table, and is reproduced on page 84 for you. And take a look, and you'll see, you can say, hey, is this an essential facility? And what did it say again? I don't think it said anything about it being an essential facility or anything like that. So I can assume I would use a 1.0 for this, because I wouldn't say it's a hazardous facility. And you could run through all those things. It says aviation control towers, anything with a lot of people in it, fire, police station, anything that's like emergency rescue, or you're going to get like large structures that have lots of people, hospital type things. And then the hazardous facilities, I'm guessing, if you read through it, it's like toxic explosives, things that you can justify as being hazardous. And then you can take a look, and I would just say it's a normal instance, and I would just use a importance factor of 1.0. I wouldn't increase it in this case for anything. seismic wise. Alright, so there we are. We have Z equals 0.4, I equals 1.0, C we assumed was worst case, use a max of 2.75 equals. Now we need to go to RW. And if you remember, the RW coefficient is a coefficient that's based on what type of like lateral bracing system. You can have moment frames, you can have shear walls, etc., etc. And you can actually find this on page 90, table 16-N. It's reproduced from the UBC. And it says table 16-N, I think I said that already. Structural systems. And let's go ahead and take a look. Is it a bearing? What did we have again? Once again, it said we have a 3-story apartment building in seismic zone 4, has a wood-framed bearing walls with plywood shear panels. So we need to figure out where is that best looking. It's not a dual system. A dual system I would look at like if it has 2 different types of framing systems. Like if it has for instance, if it has a shear wall and braces, so it has a shear wall and then add on top of it, so that's kind of a dual system. Or you could have the bracing plus moment frames. Alright, anyways, where were we at? Bearing wall system. That sounds like what we're looking for. Light frame walls with shear panels. That sounds almost exactly what we're looking for. So let's go down. It says wood structural panel walls for structural 3 stories or less. That looks pretty darn good. I'm thinking it's an RW of 8, and it's I would use, and maybe you just come down here, and if you're on your calcs, and obviously I'm not doing things like I would on my calc paper, but you can do RW right below all your stuff that you've done already, and you could say RW of 8. And then you could write maybe light framed walls with shear panels. Obviously this is a lot to write, so maybe you don't want to do that. Or you could even just go through here if you're wanting to, if you're not doing a test, don't even worry about any of this stuff. You just put 1 point, actually you just do table 16 in, I would do UBC ahead of that, UBC table 16 in, and then maybe just put like 1.1 dot A, 1 to 1A, and that'll tell you where you got that from. And once again, you don't need to do this, especially if you're just doing it on a test. Nobody cares about that stuff. Don't do it. So let's go ahead and solve. I know I've been talking a lot and not doing enough of this, but I'm trying to teach you what I'm going through when I'm going through these problems, so hopefully that's helpful. If not, just ignore me. Look at the end, skip through. Alright, C, our exception for was 2.75, and then our RW is 8, and then that's going to be a percentage of our load, which we say is W, and therefore, let's see what we get, 0.4 times 1 times 2.75 times divided by 8. And we get 0.1375. And that's not percentage. It's not one. It's actually equals 13.75%. So this is as a decimal. And once again, that could get confusing. You could say, oh, it's only 0.013%, which is next to nothing. No, it's actually 13.75%. So you actually multiply it by that. I hope that makes sense to you. I'm not going to go into it much further. So it's 0.1375 W. All right. Excellent. And that's our answer. It asks us what is the percentage of dead load of the building, and it's 13.75% of dead load. So you just take whatever your dead load is, multiply it by 13.75, and you would get your shear. And I think a good diagram to think of this about is to go back on page, what page was that? Because you're most likely on the next example have to go back here and do some more problems to figure out. But anyways, I'm not seeing what page it was. Oh, there it is. This is actually on the next page, on page 93. You can see where we'll use this V, where we just got this V. It's it goes on that bottom base shear V in that diagram where it shows a 8-story building. And we'll go probably on the next few examples, we'll go and we'll figure out how to find out what FT is and FX is for each floor. So I will see you on the next example.